Given real numbers a and b and a positive number r, let n a b r be the number of integer pairs x and y such that the distance between the points x, y, and a, b is less than or equal to r. For example, we see that n 1.20, 1.5 is equal to 7. And there's a diagram given here. I won't retrace the diagram, but there are 7 dots inside that circle. Explain why n is 0.5, 0.5 r is a multiple of 4 for any value of r. Okay, well, this I don't know if the best way to do this is by sketching a diagram and arguing something, or by working with something a little bit more sort of algebraic. So if I mark out grid points, actually maybe this will be better to do with graph paper. I want to first get a little bit of intuition as to why this works exactly. So we'll take the points of the graph paper to be the grid points. So we're given, that's the center of our circle. And if we draw any circle, then the number of grid points is going to be a multiple of 4, the number of grid points inside the circle. This is clearly, I mean, true for small values of r. Like if r is, if the first 4 points that are hit are those 4 grid points there, that's obviously a multiple of 4. I think the best way to do this is more algebraically, right? Let's so we're looking for x minus a half squared plus y minus a half squared is less than or equal to. It doesn't really matter, right? But less than or equal to r. So for very small values of r, the number of points in here, the number of x and y that satisfy this will be 0. So what I'd like to do is show that if I have equality, then the number of points, the number of integers x and y which can satisfy this is a multiple of 4. And then it'll be true also for the inequality, because you just have to add up how many add up the points, the number of points that work. But this is weird. The number. Could we argue this through symmetry? There are the grid is rotationally symmetric around this point at 90-degree, 90-degree rotational symmetries around this point. And so for any point in the circle, there are exactly 3 others in the circle. They'll just be rotated by 90 degrees around this point. I think that's the best way to explain this. So if x, y are in the circle, then when I say it like this, if v is equal to xy is in the circle, then TV is also, where T is rotation, around this point. (90-degree rotation. So yeah, if you have one point that's inside the circle, you automatically have 4. So, well, you automatically have 3 more, which are distinct. So they have to be a multiple of 4. I think that's pretty much all I'm going to say about this one. Maybe there's like some kind of algebraic way to work this out, but I think I like this rotation way of thinking about things because it really, there's no way around it, basically. Yeah, I'll leave it at that. Thanks for watching.